Okay, so what we found earlier is that if I have the matrix A and I multiply that by the vector x, I'm going to get out another vector b. And we found that using the identity of what's called this inverse, we were able to rearrange the equation into x is equal to a inverse b. And the next step is to find the inverse, okay, which is a inverse. So we can use the form that if we've got the matrix A times the identity, it's the same as the identity times A inverse. And so we start to see here that there is actually a difference as to which way you multiply out the matrices. And this here comes from the fact that A inverse is equal to I, and I is equal to A inverse A. Okay. So we can use our rules of solving simultaneous equations to rearrange the matrix. So what we're going to form is we're going to form what's called an augmented matrix. So we're going to augment together A and the identity. And so let's have the matrix we had before, 2, 3, 1, 2, and this line here means that I'm going to augment or put together the matrix with the identity. And basically this means that we're going to do a whole bunch of operations in order to turn this side here into I, and all those operations are going to transfer over to this side, and over here we're going to end up at the very end with A inverse. Okay? So the first thing we know about solving simultaneous equations is that we can add multiples of the different rows together, and so the first thing I'm going to do is I know that I can quite easily rearrange these two rows. So if I rearrange them, I'm going to get 1, 2, 0, 1, and I'm going to get 2, 3, 1, 0, and they mean exactly the same thing. So that's we can rearrange them. The next thing I can do is I can subtract off 2 times the first row. So this is the first row, this is the second row. And in doing that, I maintain the same along the top. And I get 2 minus 2 times 1, which is going to be 2. So it's 2 minus 2. 2 minus 2 times 1. So it's going to be 0. And I'm going to get 3 minus 2 times 2, which is 4. So 3 minus 4 is negative 1. And I'm going to get 1 minus 2 times 0. So that's just going to be 1. And I'm going to get 0 minus 2 times 1. So I'm going to get 0 minus 2 times 1, which is 2. Okay, so that's the first thing I did. Now I'm going to multiply this whole row here by negative 1, because that's another thing we know. We can multiply rows by numbers, and we can subtract off multiple rows off each other. So this becomes 1, 2, 0, 1, 0, 1, negative 1, 2. The next thing I'm going to do is I'm going to try and get rid of this 2 here. And so I can subtract 2 times the second row. And doing that, I'm going to get 1. This stays exactly the same. I'm going to get 2 minus 2 times 1, which is 2. And so that's going to give me 0. I'm going to get 0 minus 2 times negative 1. So let's do that. So that's 0 minus 2 times negative 1. 0 minus negative 2. So that's 0 plus 2. Okay, so that's always a little you just have to make sure that your negative signs are okay, and so I always write out the ones that are complicated or that are prone to error. So the second one is going to be 1 minus 2 times 2, and so that's 1 minus 2 times 2, so that's 1 minus 4, and so that's going to be negative 3. And so we've now rearranged this so that on the left hand side we've got the identity, and on the right hand side we've got the A inverse. And so what we've got is A inverse is equal to 2 minus 3, negative 1, and 2. And this is really, really nice. And this is how the computer solves the equation and finds the inverse of a matrix. However, there's simpler ways of finding the inverse of the matrix, and that's what we're going to go on to next. And that involves just flipping a few entries around and taking the negative and finding a factor out the front to multiply A by. So we'll see how that works. Oh, I should probably show you that this actually works. So if we've got x, which is equal to y and x, and that's going to be equal to A inverse, which is 2, negative 3, negative 1, 2. And we've got the vector B, which is 5 and 9. Okay, well let's do matrix multiplication on this. So we're going to take the row along here, and we're going to dive it down into the column here. So we're going to get 2 times 5, which is 10, plus 3 times 9, which is 27. We're going to get the second row, which is going to be negative 1 times 5, which is negative 5. And we're going to add that to 2 times 9, which is 18. And you will find that if we add these together, we get one second, this is a negative 3, sorry, so this is I'll just get a little eraser. It's one of the problems with covering up your notes with pen. This is negative because we've got a negative 3 here. Sorry, I covered that up when I drew the line across. So we're going to have 10 minus 27, and that's going to be minus 17. And we're going to have negative 5 plus 18, and that is going to equal 13. And that's what we got earlier. That makes sense according to our picture that we drew earlier, where we had 2 lines here, and we saw that they intersect here at positive x and negative y. So that works really well. So y is equal to negative 17 and x is equal to 13. And I mean, the reason why we do all of this matrix stuff is that we can do this in the computer incredibly easily. We type out the matrix A is equal to 2, 3, 1, 2. We write that B is equal to 5, 9, and then we write into the computer A to the power of negative 1 times B, and that's how we get out our vector x. And so it's incredibly easy to do this on the